Okay, so we have quite the lineup today for OpenPBR. Look, it's so great that we have folks who have been working on this, who are the experts on this across Autodesk, Adobe, and Lucasfilm. And huge thanks here to Henrik for pulling this all together and getting all the folks together. So we have Henrik from Autodesk, Julien from Adobe, Frédéric from Autodesk, Jonathan Stone from Lucasfilm, Guido, who everyone knows from Adobe, and Adrien from Autodesk. So I'll stop my screen share, and who's going on first?
I'm going to share the screen, but let Guido do the introduction.
Perfect.
Yeah, I'll do a quick intro for actually some of you. This may be, you may see some of the slide that is similar to what was presented during SIGGRAPH. But this is just, we want to give an opportunity to go through OpenPBR, the presentation again, and obviously have plenty of time for questions and what's the next steps are. So again, some of you may know, some may not, this has been a great collaboration between Adobe and Autodesk that has been going on for the last few months. And really the goal was to see if we can find a common material between the Autodesk standard surface and the Adobe standard material. And again, we started from the assumption that artists want to use many applications. Interop is really a key aspect to be able to take advantage of all these applications in a seamless way. And the look is definitely, the look difference is still a big problem. Material X is really coming to help in this area. And on top of that, we thought also absolutely let's work close with Material X, but at the same time, let's see if we can identify a general material with different components that we feel good about it as something that can carry forward some of the thoughts that were done with the standard surface and the standard material from the two companies. And hopefully this will be a beginning of something that is out in the open and with collaboration with all the other vendors, artists, studios, etc., to be able to continue to innovate going forward. So this was not yet another one. Hopefully, the hope at least is to go from 2 to 1, but even more as we look into the future, see if we can actually consolidate even more. And again, within the umbrella of Material X, this was a key aspect. We didn't want to create a new governance model and introduce a bunch of other meetings, etc. We thought, we really believe in both companies. We believe in the Material X as a standardization for the future. So we thought, why not be part of it? And I think I'll leave it to a video that is probably speak by itself. I don't think there is audio coming through, but you can read through the text and explain a little bit more what I just said.
Maybe I can explain a little bit. So when we worked on OpenPBR, we needed, some scene to try to compare and see as a proof of concept. So Nikki has been making this scene, and we've done what we could to make it work both on Arnold and the renderer we have at Adobe, and trying to see if this worked. So this is all a prototype. We don't have a final implementation, but Nikki was already super positive about that, about the ability to get some similar result in both cases, even though there are some differences. It's not pixel perfect, but we already had some super good feedback about that.
Yeah, the idea fundamentally to be able to make judgment calls, you do renders in multiple software, but you can do judgment calls that are actually good qualitative judgment call about what you're seeing. And that's where we strive for it, even if it's not going to be, if you do an image diff, you may still see obviously differences between the pixels. And I think next is Adrien. Talk a little bit more about the technology.
I'm going to give a technical overview of the OpenPBR surface. So practically, OpenPBR surface is a physically based surface model that is based on Autodesk standard surface and Adobe standard material. It means that it's designed as an inverse surface shader, and it aims to be capable of accurately modeling the vast majority of materials that are used in production. It's an evolution of 2 production-proven models with a clear continuity as shown by how close the layering diagrams are in all three models. And the parameters are designed to be intuitive and to ensure that users work within the bounds of what is physically plausible as much as possible, though always with the ability to tweak reality in well-defined ways and achieve exactly the look they want. Users of both models or any PBR model will find the familiar metal, glossy, diffuse, specular transitions, sheen offers, SSS that they already know to use well. Julien, want to go next slide? Yeah, thank you. So our goal is to create a surface shading model that is able to faithfully represent a wide variety of real-world materials. And real-world materials such as finished wood or cloth or skin, they all comprise in semi-transparent layers of matter that is stacked on top of each other. So to match that, we define the model by describing the physical structure as unambiguously as possible, rather than by specifying a particular form or implementation. And we have two basic operations that are layering and mixing, and they provide language for building a model of material consisting of slabs of material with structure that is varying horizontally over the surface. And this formalism is generally enough to describe arbitrary complex materials. And the specification is written so that people can implement it in the renderer faithfully. And we are also working on implementation of OpenPBR in Autodesk and Adobe software based on the spec, and as well as our Material X specification and implementation, which should be able to be consumed in renderers that are supporting Material X directly. And Julien is now going to go over some differences we introduced in both models.
Yeah, thank you, Adrien. So yeah, when we designed OpenPBR, like we essentially merged the Autodesk standard surface and Adobe standard material. And when there were differences, like there was a lot of in common, but when there were differences, we tried to take the best of both worlds. So we have a couple of examples here to show how like OpenPBR differed from its roots. So first here, inspired by standard surface, OpenPBR has a dedicated subsurface lobe in addition to the interior volume, and we also improved the parameterization to be even more perceptual and art directable. For example, the images on the right, so they are renders showing a material with a subsurface scattering and with the edge between the lit region at the top and the shadowed one at the bottom. And the scatter radius now controls the average distance that light travels along the surface after multiple scattering. So the overall subsurface effect looks similar regardless of the color. The rightmost material has forward scattering, and we have formulated anisotropy in such a way that it does not affect the overall color or scale of the subsurface effect, while still giving the edge softening and directional effect that you would expect. Another example is metal reflectivity. So OpenPBR inherits the F82 tint reflectivity model that we had in Adobe standard material. And this is a model that takes two parameters, base color and an edge tint with the default value of 1. So the default value is essentially the Schlick Fresnel. And this lets you accurately reproduce the dip in reflectivity that you have with the real metals at near grazing angles, while still being art directable. So, well, it's a little bit difficult to see given the size of the picture and how subtle it is, but on the left you have a variety of metals using the base and edge colors that are derived from measured spectral data and the full Fresnel equations. And the images on the right, they show a couple of examples of this model applied to a metal sphere within a white furnace. So the intuitive results are produced for any combination of base and edge color, essentially. Finally, here is an example where OpenPBR differs from both Adobe standard material and Autodesk standard surface. That is the layering. So for example, we've moved the fuzz layer on top of the coat and emissive layer, and that reordering increases the what you can do with fuzz. So for example, here on the illustration, so on the left you have like a base metal, very simple, and in the central picture you add some blue coat on it, and the rightmost picture you add some fuzz on top of it, and that allows you to model some, say, like coated dusty metal. Now giving the hand to Jonathan to give some perspective from Material X.
Thanks so much, Julien. So yeah, I can talk a bit about the relationship between OpenPBR and the Academy Software Foundation and the Material X project. So as Guido noted at the beginning, OpenPBR is a sub-project of Material X within the Academy Software Foundation. That allows us to leverage the existing Material X TSC meeting structure. It gives us an open governance model where no one company dominates, and we'll be able to invite more and more companies into the fold over time. There's a reference implementation of OpenPBR in Material X. It's in progress, but it'll be a part of the open release. This will give us the ability to bring OpenPBR automatically into applications that already support Material X. So in tools like Houdini Solaris and Omniverse and Maya USD, any place where you could render standard surface before, you'll be able to render OpenPBR automatically just by upgrading the Material X version. Additionally, we're able to leverage the versioning system in Material X, which is very important as no shading model is permanent. The industry and its state-of-the-art will evolve over time, and we need the ability to upgrade assets and upgrade the OpenPBR shading model in a way that doesn't invalidate assets that were created in the past. And Material X has a rigorous framework for achieving that. Finally, all the technical steering committee meetings of OpenPBR will be open to the entire community, and we'll be encouraging people to come in with suggestions and questions. And it'll be just as open as the process currently is for developing the Material X project itself.
And handing it to Frédéric for closing words.
Thank you, Adrien. So yeah, some concluding thoughts on OpenPBR. So far, in the beginning, we were very cautious about the collaboration between Autodesk and Adobe. We weren't sure if we were going to be converging, but very quickly we realized that the convergence was possible. And ever since, the collaboration's been great and done in really good spirits. So thank you to both teams for making it happen. And we've always thought of finding the right balance between expressivity, physical correctness, and ease of use. And it's a tricky exercise, but I think that's what is driving us for the design. So I want to highlight that OpenPBR not only eases the exchange of assets between software vendors or studios, but also it presents our common users a familiar set of parameters and concepts for the layering in all the applications that they use in production. So that makes it easy to jump from one application to the other. Also, thank you, Jonathan, for helping us, hosting the project under Material X. I think this clearly states that OpenPBR is an open standard, and we also have shared, an early draft of OpenPBR with a number of people from the industry, a number of companies, and we've received feedback already from those early access users. Especially, I want to thank the Blender Foundation, NVIDIA, and Pixar for the very interesting feedback. We're going to open this to wider public soon. Also, I want to thank Side Effects for providing this render done in Karma with the draft specification, showing their commitment. Again, thank you for that. And finally, I'd like to say that OpenPBR is not just a spec. We're really committed to shipping it in our products. So we showed it in action, like a whip version of it at SIGGRAPH on the Autodesk booth. You saw it in the video, but we showed it in Maya live. People could try it and stuff. We also are planning to ship it in the Arnold betas very soon, so that we can get feedback from even a wider audience, from our users, from the artists. So yeah, so stay tuned. And last thought is that OpenPBR surface, and note that it's a first step, and we're planning to working on other material models, for example, that we need in production, such as hair or volume, and we'll need your help then also. Lastly, thank you for all to all the contributors of OpenPBR so far. Here's a lineup, and that ends this presentation.
Really awesome.
Thanks.
Yeah, thanks all for the presentation and all the enthusiasm there. I'm sure there'll be a lot of questions. Who has the first one? Maybe you're still on mute.
Yes, sorry. Thanks. Yeah, that is a great looking presentation. And I have to say, it looks very, very familiar and well aligned with, I think, what we've been working on for quite a while at the glTF PBR side of things. Again, bringing together the Adobe and Autodesk and Dassault and such standards to try to make one physically based system. So that's awesome. I'm guessing, I mean, it seems like the natural thing here is obviously we need a standard at the sort of authoring format side of things, and looking at sort of, I'm guessing that's where sort of the Material X side is coming into this. So that's fantastic, because I think that would be really valuable. But have you sort of looked at like how that should come together? Because it definitely seems a little bit silly for us to define physical parameters in two different ways. Although honestly, we were looking at OpenPBR, it seems like it's pretty much compatible with glTF. Actually, the one thing that we noticed was kind of funny. You talked about moving the fuzz layer on top. We actually had our own debate at the PBR Next call when we were doing Sheen and saying, shouldn't this be on top because it could be dusty? And then they said, well, but Autodesk and Adobe both put it under, so I guess we'll just leave it under to be compatible. But we actually, upon seeing that in OpenPBR and hearing from Adobe and Autodesk, they're like, actually, we're probably going to change that now. We're like, well, actually, that seems like the kind of thing we can probably get away with changing within our own spec at this point, because it seems pretty reasonable. We need to go talk to some of the implementers and such to double check. But so I'm just curious, I'd love to kind of find out, like, how do you want to look at that? Is there a way to do it as a collaboration? We talked about making our specs public anyway, so they could be reusable. You were talking about doing hair and volume. We have volume specs. We have anisotropy specs. You'd probably want to add some more for hair. Just would love to hear your thoughts on kind of how you would like to see that collaboration go.
Well, if I can just say, sort of like, I would try to get into a room with, I observed the team are really coming together and really figuring out all those little things about what goes on top and how do we name things and all that. I think it'd be interesting to do like a few sessions together to really go through it and see if in fact there is little things that can be done to really make it closer and closer and closer, even if potentially we may not have exactly the same thing because of obvious reason between authoring and be able to final quality render versus real time, but maybe be a path that it becomes smoother and smoother. So when we convert and when we interop, it becomes easier. So, I mean, it sounds pretty obviously stating the obvious, but I would really consider organizing like maybe not a huge group, like, really the core team of OpenPBR and some of the core team of the effort on the glTF to just go through things, and there may be some things that are obvious and they're easy to knock off. I would say there have been a lot of thoughts and time spent in OpenPBR, but things are made also to be changed and evolved. So if there is anything that can be adjusted, so I'm pretty much, I want to be clear, it's not something that has to be one way, like, this is it and everybody has to adopt that. Now is actually a good timing to have this conversation to see there's convergence possible.
Yeah, and I guess just maybe the main thing, I'm curious what your concerns are in the first place. Just sort of, because I mean, obviously we could have started, I think, OpenPBR from our own PBR group if anybody had wanted to. And I'm just curious because I know glTF is primarily a real-time format, but we did design PBR specifically with the goal of being agnostic between real-time and path trace style renderers, right? That's why it's always been focused very much so on physicality rather than on the particular implementations and approximations used. I'm curious if there's anything that's sort of brings trepidation in terms of what you would need for a standard in the authoring world.
Anybody else wants to answer this? I just don't want to take the center stage.
I didn't quite get, like, what do we need? Like, could you? I didn't quite get what you're asking. Sorry.
I guess what I mean is we do have a specification that standardizes this PBR stuff, right? This does exist before OpenPBR started. Presumably.
Would you mean the GLTF?
Yeah, exactly. The specifically
well, we have,
PBR
like, okay, yeah. Well, we all have. So, but
as in we specifically have a PBR spec that is bringing together the various existing PBR methods of the different companies involved, right? And those were all members of our PBR spec. So I was just curious, like, was there a particular thing where you looked at that and said, well,
I think they're looking for
can't make use of that because of this? I'm just trying to figure out if there's like
differences. I think it's because it's non-real time, right? I think that's it.
Real time has nothing to do with it. It's just no. I mean, like if we look historically between Adobe and Autodesk, Guido reached out. Like, we were thinking of making. We did standard surface, the spec. Adobe did standard material, and Guido reached out at some point. Thank you, Guido, to say, well, we're thinking of making our standard evolve, but it's very similar to standard surface, which is widely used in the industry. So maybe we could converge. So, and thank you, Guido, for reaching out. And yeah, we started from our own products and specs. And the like standard surface is implemented everywhere, so it seems like a good start for our segment of the industry to start from this. The like de facto, when people need to exchange assets that have kind of an interesting look. I mean, in the M&E world. They use standard surface. So let's make this a spec that is more open. We've attempted to do it before, but like there was some doubts about the openness of it or the governance. I think now with the collaboration between two major software vendors that are providing widely used tools to author materials in particular. And render them, placing this under the Academy Software Foundation governance and Material X. I think this is a very strong signal. So why did we start where we started? Because that's where we come from, I guess. I mean, as for the involvement of how we could collaborate and convert with glTF. I think we need to. I think it's desirable. I think I don't know how. Let's discuss this. There's no as far as I'm concerned, I'm speaking for myself, and not like there's no. There is a desire to converge. I don't know how it will happen, but yeah, let's discuss this, right? But there's no barrier for this. Like, so the main reason why this structure is, I think, historical.
Yeah, and also, if I can add, we didn't know how to do it even when we started with Adobe and Autodesk, because it's a fairly new thing. I think we just went both sides open-ended about like just say, okay, let's discuss it. That's what I was saying. I don't think there are two things. I don't think it's worth looking at, oh, we have this and we have that, because I think everybody, again, had something. And real time and not real time, again, because it may be immediately, if we start going down that path, we say, okay, clearly we need two then, or we have because of those reasons. My suggestion would be, again, get into a room, go through things, and make sure that we have a balanced conversation where on both sides we can respect and understand the needs and the requirements, and because that's what we did in this first phase, and see where we land. We may quickly land oh my God, definitely we are in a two different planets, and maybe that's the way it is, but maybe not. And that's actually the thing that was the positive surprise, at least in observing the two teams, because we thought, just to be totally frank, installed base. Adobe was really pleased to see the Autodesk people really try to figure out what's the best answer to this. Not like, well, we have way many more users, so we're going to stick with that. So I think the conversation would be more, let's get into a room and just present and explain the rationale between some of the decision. Step back and see, like you said it before, like I said, well, actually, instead of doing it this way, maybe we'll do it the PBR way. And maybe OpenPBR will say, you know what, that thing that you did in the PBR for glTF maybe actually makes sense. Those are, takes time. They're tricky at times, but I think it's worth doing it because, again, we just do it for the end user at the end. And so I think it's time well spent, I believe.
Just expanding a bit on what Frédéric and Guido were saying, I think as has been discussed here, one of the big motivations for OpenPBR was to bring existing projects from Autodesk and Adobe under an open governance model, and to essentially consolidate two shading models that were similar but not identical into one that both companies can move forward with and that is useful more broadly in the industry. I think the alignment between OpenPBR and glTF PBR is extremely valuable to discuss, but not because we need to unify them into a single model necessarily, but because translating between those models, for which many assets will exist in the industry, needs to be as robust and accurate as possible. So any place where we can align the two more closely, I think will improve the quality of shader translation across those two models. But I don't see it as necessary to have one shading model that rules the entire industry. Yeah. I think having multiple shading models that are useful in different contexts with rigorous pathways between them is a potentially more effective and more flexible approach going forward.
Yeah, and just checking in, I mean, this is not a new initiative. It's we released the standard surfaces, like open specification was 2018, I believe. And that was after a very long collaboration with many partners throughout the industries. It was not just coming from Autodesk. So this just builds on that, and this precedes the glTF PBR work. And I think when we started that work, it was also a little bit unclear. I mean, glTF has certain design goals of being a last mile format and optimized for delivery and all of that. Whereas, we can, with standard surface, more from the authoring perspective, like no compromises. Well, apart from what Fred mentioned, we need to balance flexibility, physical accuracy, and simplicity, usability. But we don't have necessarily the limitations that it needs to be portable everywhere, the full shading model. So it just came from different perspectives. But I'm super curious, like anxious to get that alignment sorted out between what's happening in the glTF PBR working group, which I'm obviously part of myself. And what we're doing now with OpenPBR. But if everything started from scratch in the last year, I think we might have started working closer with the work that was already happening in the glTF PBR. But this goes back almost a decade, so there is some historical context there that led to where we are today.
I mean, this all makes a lot of sense to me. I think Adobe and Autodesk working together and helping, converge and unite. That's a huge positive step. And then bringing more folks into the fold to get feedback is great. This idea that Guido has around, maybe a deep dive, if you will, among the Kronos PBR and the OpenPBR, with the goal of maybe smooth translation, not necessarily being exactly the same. I think that would be an awesome, if that's one of the actions that comes out of this meeting, I think that'd be phenomenal.
I'll just note there's already some great work to do robust translation between glTF PBR, which has a Material X graph, and Autodesk Standard Surface, which also does. And our intent is to make the OpenPBR project not just a specification and a reference implementation for the shading model, but also reference implementations for the translations between OpenPBR and other open models that already exist in the industry. And that'll certainly include glTF PBR, almost certainly include Autodesk Standard Surface, since that is openly defined. But I think that's an important piece of the puzzle. It's not just defining a shading model as a closed system, but defining rigorously how it connects to the rest of the industry.
Yeah, for sure.
In the chat, there were a couple of questions about like our stance with regards to real-time rendering, and I thought we could answer that. Essentially, we try to be really agnostic in the spec. Like the spec is defining a material, like it's really for the artist. This is how you describe a material, and we try to give as much information as possible for the implementer. But we're not the police, like we have no control over what the implementer does, and we try to give them as much like leeway as to what they want to do with it. So in the end, like the OpenPBR is meant to be implemented both on like high-end offline rendering and real-time. And if some renderer needs to cut corner, then that's perfectly fine. That's we try to make it easy to make the spec useful for a broad range of renderers. In fact, in the spec, when we mention a model, we say like, well, this is a reference model. Like for example, in one of the say BSDF, we say like, this is a BSDF we have in mind. This is the one we think should be the reference. But if you need an approximation, we think this one is a good approximation that is cheap, etc., etc.
Yeah, if I can add.
Yep.
Sorry.
No, please go ahead.
Oh, thanks. Yeah, that's a very common question. That like, what about real time? What about real time? Well, we don't. Real time today is very different from real time in 1 year. So, this is about describing a model. We're trying to describe the model as well as possible. And if your renderer, like, or your specific use case or the platform you're running on, like, is not able to, like, has to cut corners or has to ignore some parameters or has to do simplified, handle things in a simplified way. Yeah, well, go for it. But at least the intent is still it has been authored and will, be transported from application to application with the intent preserved. So yeah, like the real time is, it's not, there's nothing that is specific to either real time or, offline. And all of this might be the same thing in the future. So, it's difficult. I'm not sure how I can explain it more, better, but I don't think it matters for a description of a model.
I'd be happy to add to that a little bit, Frédéric. So it's worth noting that there's a long history of implementing complex production quality shading models in real-time applications. In Standard Surface, there are very high quality implementations that you can use, in the Maya viewport, in Hydrostorm, in other applications, and in studios like Lucasfilm, we have our own custom shading models. But they need to work in real-time context as well. And the popular strategy that I've seen for accomplishing that is to accept approximation in the real-time implementation that you might not in a path tracer, but where any input of the shading model that an artist can tweak and they expect to have a visual impact needs to have a visual impact in real-time renderers as well. It just doesn't have to be doing the full volumetric scattering. It can be using Eric Penner's approximation or anything else that's appropriate to the application. And you see that approach used in environments like Unreal and in Unity as well. In Unreal, if you're using a framework like Substrate, you're going to get approximations of certain types of BSDF lobes when you're rendering outside the context of ray tracing that you would get accurate versions of when you're accessing in ray tracing. So I think the problem of how to approach OpenPBR in real time is very similar to a long history of approximating production shading models in real-time contexts. And there's a lot of good approaches that we can draw upon and will draw upon in the reference implementation in Material X, just as one example.
Yeah, I see a good question from Ben in the chat about, like, how, and it's related to the compliance of an implementation of OpenPBR. Like, yeah, which parameters, like we've attempted in Standard Surface to have main parameters and, like, optional parameters. Like that was the first attempt at defining what is really critical to support to be compliant with Standard Surface at the time versus something that is optional. And we put things like SSS as optional parameters. So I'm not sure this is, like, it's a bit crude. I'm not really sure what we should do. Like, if that's a very interesting topic. Like, how can you even measure the fidelity of your implementation? Is it comparison to a reference image? Which reference image? Is it a score based on the number of parameters that you support that actually do something? I don't know. We have lots of ideas. Would be great to hear what what we could have to quantify the compliance of an implementation. It's a hard problem.
Just to expand upon what Frédéric said before we go back to Ben and to Emmett, I think it's a really fascinating suggestion to have sort of a level 0, level 1 version of a shading model like OpenPBR. In my own experience in production, I have found it more powerful just to create an asset in one shading model, such as OpenPBR, and then if you need to go to a simpler version, you would just translate that over literally to glTF PBR. You wouldn't have OpenPBR A, OpenPBR B, and thus create this confusion about which is implemented in any given renderer. You would just have the shading models be exactly what they are. They're singular, but you have robust translation pathways between them. And if you need to go to glTF PBR, you just go to glTF PBR. You don't go to some mid-ground approximation.
Emmett, did you want to add something?
Yeah, so I think the key here, the last two speakers here, I think summed it up perfectly, what we need to kind of align on. So there's this concept of how you validate that a renderer is accurate. Done a bunch of work on that in glTF. Oh my gosh, we know a lot about how incredibly difficult it is. And because of that, the glTF PBR group took a different approach. And I think that difference of approach is key to understanding how OpenPBR and glTF can work together. Because I think they absolutely can. I think they're actually basically already compatible. I think with a very little bit of work, we can make this work right now, which is great. And with the right amount of coordination, I think we can keep it working. But here's the key. glTF, when people think about the real-time renderers, they think about glTF. They think about the JSON. They think about the specifics of, like, how a renderer might implement it, what particular shader they're going to use. But here's the trick. glTF does something that's a little bit special. It's just like Jonathan said, we do not specify the approximations. So the way PBR's spec works is that there are no shaders. And there are no approximations spec'd either. Schlick Fresnel, sure, everybody uses it in real time. Is it part of the spec? No. Why? Because it's approximate. It's not correct. And we are leaving the door open intentionally for a better approximation to come along in the future, that those renderers will be able to adopt without breaking the models themselves. And that's the key. The way that we spec PBR next is entirely in terms of physics and physics alone. And that's why it applies to both real-time and path tracers, because even path tracers use approximations, and we don't pick any of those either. We just say, look, this is the physics, this is the actual math of the BRDF. Nobody is going to do this right. Nobody is going to do this exactly. But everybody now knows the physical thing that we're trying to get to. And now we can drive ourselves toward better approximations over time. And that is the core goal of glTF. And that it's that part. It's not the JSON. It's not the, you know, this is a particular approximation that a renderer is using. I don't want to standardize any of that with OpenPBR. That doesn't make any sense. I don't want to standardize any of that at all. What I want to standardize is the parameters and what they mean, and the mathematical, the ideal physical mathematical equations behind them that are not shader approximated. And if we can get all of that to be standardized once and shared, then we know that we will be able to take anything from OpenPBR and write it as JSON in a glTF and have, you know, as good as whatever the real-time renderers can currently produce.
The one thing, I mean, I see the rationale behind all this, but I mean, this is a larger conversation, obviously, but also in the approximation part is a big piece if we want to make sure that things looks the same. Like, you know, because you may say, well, it doesn't look the same because of an approximation, but then if you don't specify even what this approximation is, then for us, the intent was as much as possible to make sure that, yes, sure, there is a physical definition, but there is also some form of approximation, I guess, that make it much possible to be able to make judgment calls on making it look as much as possible the same. Sorry, Frédéric,
exactly.
If I reply over you. So,
and I think that that's absolutely a valuable thing for OpenPBR to add, right? I think the fact that you can have a specific implementation based around material X that gets you really tight renderer to renderer consistency is spectacular. That's wonderful. We don't have that luxury in glTF, because if I want to be able to render this on a low-end mobile device, I simply can't run your shader, right? It's just not. I don't have enough GPU power to do that. And that's why glTF gives us this much greater flexibility than OpenPBR probably would. However, here's the beauty of it. We could still share that physical level, even if you specify a particular shading model to be like sort of OpenPBR compliant, and we allow a much broader set of shading models to approximate that at the real-time step. But if we can agree on the actual idealized physical equations, that can be completely shared. And that would make it incredibly easy to interoperate.
Yeah, that's a great point. And that's, I think, that's still debated, you know, even internally, and also from the feedback we're getting. But it is an idea that we had also, and have only recommendations on the implementation. But it depends. Like, we have the additional constraint maybe that we want to exchange the look. We want to exchange the look between two studios, between two software for a current production. So to have, like, you know, to transport the look and make sure it's as accurate as possible. So you need some detail on the implementation. But I'm with you. I'm with you on that. Another thing also is that we have to break the physical model sometimes. We've added lots of parameters in there that are not, well, that can be tweaked out of the physicality. You know, we try to define like physical boundaries, but you sometimes in production, you have to break them because the director wants it, because it looks better, because it hides something. You know, there's some cases like this. And when designing OpenPBR, so it goes back to a question you had earlier. We wanted, like, today we support those cases with Stand Surface. Like, our customers need those, and we wanted to have a standard that will be as expressive as what we had, because we want to use it today. We don't want to have something that is not as expressive as what we had. Like, you know,
can you give an example of one of those non-physical parameters, or maybe something that's missing from glTF's PBR that you've found lacking, just so I can grab onto something?
One example would be the speculatin, for example. Like we have this parameter where the artist can just say, well, whatever comes out of the specular lobe is tinted green, and that's non-physical, but sometimes they want it to, you know, to imitate a coating lens or something like that, for example.
Well, we actually have exactly that same parameter in the specular extension of glTF, so I guess we've agreed.
A more difficult one that is currently being discussed is at the interface between the coating and the substrate underneath. We're currently discussing like how the coating should affect what's underneath. And if you think of, say, for example, like if you spill water on some sand on the beach, the water you could represent that with like as a coating, but as it infiltrates the sand underneath, it's modifying the properties of the substrate. It's modifying the diffuse color of the sand. And then we're like, okay, like what do we do? Because in some cases, the artist is going to be to want the coating not to affect what's underneath, and it's on other cases they will want to affect it, and we don't really have a model for that. So now we're questioning, okay, should we introduce a parameter that says the coat does or does not affect the color of what's underneath? This is currently an open question, but that might lead to a non-physical parameter.
Oh, interesting. So you wouldn't just say that they should modify the base color if it modifies the base color? You want to have like a way to automatically merge the two together? Is that kind of the idea?
There doesn't like at this point in the discussion, it's not clear that there is a satisfying answer to that, because like we had the code affect the color and our artist was surprised by the result they were getting, but on the other hand, like we know there are some use cases where we would want that, and if we don't, then the artist would have to change the base color of the base substrate, and maybe they don't want to have to go through those hoops. So
yeah, when we discuss things like that on the glTF side, and I don't know if this is valuable for the OpenPBR, we tend to say that we split up what's in the spec from what's in sort of authoring tool chains. And we try to say, like, yes, there are things that you want to do to make it easy for an artist to change a parameter, and that might involve changing multiple parameters down underneath in our actual representation. But on the spec layer, we focus mostly on keeping things as physical and simple as possible. So when we take things like that, we'll usually say, like, well, it seems reasonable that a authoring tool could make that adjustment automatically for an artist if they deemed it valuable, but we wouldn't really need a spec change to represent it. So I don't know if that's helpful for your discussions.
Hey folks, so we just have a few minutes left, but I'm hoping if anyone can even stay on after the end time, we could continue some water cooler conversation. So I just kind of want to pause for a moment. I've loved kind of all the discussion around glTF PBR and OpenPBR and ways that we could collaborate and potentially align. I wanted to ask maybe though, is there anyone on the call who has questions beyond the glTF PBR stuff that they might want to ask about OpenPBR? Okay.
Do we have a full spec released? Sorry, do we have a full spec released yet? No. Or can you guys link to it?
Not just yet. Very soon.
Okay, that would be very, very awesome.
We're talking, I dare say, weeks. Okay.
That's awesome. Congratulations.
Yeah, this is huge.
Okay, well, any other question, whether it's glTF and OpenPBR or just broad OpenPBR questions?
I have a question.
Awesome.
What's next with our collaboration with glTF? Well, what would be a good next step?
Have any of you read our PBR specs by chance? They're all in their own extensions, but it would be interesting to read through our sort of what parts of our spec are normative versus non-normative. I think we'd only be interested in sharing the normative parts with you. That's the physical bits. It would be really interesting. Like, we've already looked at OpenPBR and found it to be nearly identical to what we have.
SSS
which makes sense because it's coming from the same sources and the same collaborating companies. it would be wonderful to see from your perspective if you see differences. Because I honestly think it would take very little to iron out whatever tiny changes remain. And then we could simply come out and say, these things are already compatible. And I think that that would be a huge message for the industry.
Cool.
So it sounds to me like we need to set up some additional meetings, maybe on we could host it on the Kronos IP free line, or we could maybe have an offshoot of one of the MSF Zoom lines. I don't know. But it sounds like we need sort of work sessions to hammer out and understand where the differences are and what would need to be done to bring this into further alignment. I don't know if there's a particular day or time that would be better for people to join such a meeting.
A lot of us are based in Europe. So this is about as late as we can do. But yeah, maybe it would be better to like if you have access to, if you're lucky enough to have access to the draft, like please give us feedback as soon as possible, because it's, you know, we're closing in on version 1. So yes, please give us the feedback, and then maybe it would be the right time to start a discussion and have another meeting with glTF. What do you think? It might be premature before.
It sounds like a good idea. Emmett, I think you got early access to that draft, if I recall. Yeah, we should have a few of our members review that and try and really understand in depth what the details are. And then set up some additional meetings to sort of hammer it out.
I'll just
So
note,
maybe,
sorry,
go ahead,
just one
Jonathan.
last thought. Yeah, I'll just note, I think there's huge value in improving the alignment between OpenPBR and glTF PBR to create better pathways between them, but I wouldn't want to set up a structure where we're tying the hands of either of these groups to make changes in the future, to evolve in directions that make sense for their constituents, and they may not always align. So I think aligning is extremely valuable, but I think tying the two together in a permanent way, it might just not benefit anyone. And I think having a flexible system where they can evolve in tandem and the pathways between them remain robust, to my mind, that seems like the most valuable way forward, and it doesn't limit one based on the needs of the other.
Yeah, I fully agree. I would say in the next couple of weeks or before we finalize, just as I think it can be a good exercise to get it, and maybe we can sync back between the Autodesk Adobe group to see how can we do a sync up, just again to make sure that there are not some obvious things that are, oh, okay, that seems like a good thing to have a conversation. But I agree with you, Jonathan. We don't want to say, well, we're going to hold it until we get to some place of unification. But it may not hurt to do just an hour or two together, maybe do some homework before, get together, take a look at the even just the parameter space initially, and to see if there is anything worth at least having a conversation just to start. And then, obviously we'll see how that evolves into.
Look, I think that all sounds great. And was there any materials that needed to be exchanged? Like Emmett, at one point you said there's normative spec for Kronos PBR that I guess you've been decoupling from glTF that we could share with folks. Is that right?
Yeah, I mean, it's all just the regular old Kronos specs. It's just when you read through them, if you note, there are these little like non-normative section headlines, and it's really important to read those because we put those in very specifically to say, hey, we're giving some guidance on how to write a shader for a real-time model, but this is not part of the spec. This is just a suggestion. It's the normative parts that are purely physical and are not implementation specific and are not real-time specific. So I just want to make sure when you read the specs that you make special note of that distinction.
Cool. But then Guido, in terms of having the groups chat together, is that, I mean, would you want to organize that, or would it make sense for Ed Mack?
let me do a thread internally with the team where the team is in terms of consolidation and the rest of the other feedback, and see if it's something that we can put together in the next few weeks, because I think, again, I don't think it can be hurtful to at least have that. And again, it's not going to block in any way or form, but I think it would be good to know. For me, it would be just interested also to see if there are, what kind of distances there are, especially for the interop, exactly what Jonathan is talking about it, because that's ultimately what we want to make sure that we don't end up with some, something that we could have addressed sooner than later for simplifying interop.